All right, so we will continue where we left off. This is part 2. Let me share my screen. Yeah. Okay, let me screen right there. What were we doing? We were doing this interquartile range. Okay. So we got the interquartile range, right? We're gonna multiply the interquartile range by 1.5, and we're gonna add or subtract from Q1 and add it to Q3 to figure out our whiskers, A and E. So let's do that. I'll just write it out just to be safe for everyone. More steps, but hopefully don't lose anyone. So 52.875. We're gonna take that right here. Q1 is this 4.7 minus 1.5 times IQR, or that's again, I'll just keep doing it so that. But again, this would just be this entire part. This entire would just be 52.87. There you go. That's not exactly A, and I'll tell you why in a bit, but you'll see. So something. In this case, it's quartile 3, right? Quartile 3 right here. Quartile 3 plus times that. Okay. This, place it here, and make a sign. Okay. So this is how we're going to determine our A and our E, right? So if we put C, for example, C is the median, right? The median is what you would get if you looked at the center of this data set and find the median. It's what you would get if you just used this exact the IF formula that I did to find Q1 and Q3, but instead of 0.75 or 0.25, you just use 0.5. You would also get 495. And so that's the median, 495, C, right? B and D is quartiles 1 and quartiles 3. So B is quartile 3, 512.5. I guess around it. Well, it's close enough, right? There you go. Quartile D is, quartile 1 is D, which is 477, right here, right here. F is the outlier, so we'll get to that in a bit. But now we got to know A and E. But A and E isn't technically this, because none of the data set is actually this number. Like there's no data in this series of data points that is exactly this number, right? So if we look at this, let's just work with A first, right? A. Anything above this number is, anything above this number is an outlier, right? And so, okay, it will make more sense if I start with E then, sorry. So E, anything below this number is an outlier, right? So in this entire data set, what number is below 424. All right. So 424 is right here, right there. So all these numbers right here are outliers. Okay. And so anything below this bar is an outlier, right? All these little points were all those data points. The F is the smallest one because it's all the way at the bottom. The smallest number was 370. Now, what is that bar though? That bar isn't this. That bar is the first data point above this, right? So below this number, below 424.125, all outliers, all dots. Above this is the first data point above this is E. And the first data point above 424 is 432. So our E is 432, right? Same thing with A, right? Anything above A is dots, outliers, and the first thing below below A or below this is A, right? So what is above this? Well, there's nothing above this. So there's no outliers above, right? There's only outliers below. And so the very first value below this is 564, which is why 564 is A. Right? Okay. So moving on. That's how you get the box plot, the whiskers, using this stuff, right? IQR, IF. I will save this document and send it to you all. I don't think it's like something important. So moving on. Number 37, 27. It wants you to find the sum of squares. Okay, sum of squares. Find the formula on the PowerPoints or look up Google, which is what I'm gonna do right now. Look up on Google and save this formula onto your little note sheet. Squares. I know there's two formulas for this. Images right here. Open. This is the formula. So you can either do it with this method or you can do it with this method. This method is easier, but you can do it with this method. This is why knowing how to read summation equations is crucial, because if you don't, you would look at this and you would say, what the frick is going on, right? So we're gonna use this equation basically. So what this is saying is you're gonna take these sum of x of I squared. So that means every single individual value is squared and then added together, right? As compared to this one that adds every single value, every single x together, and then squares them. This one squares each one first and then adds them, okay? Because it's inside the bracket. And so we'll use this formula right here. So how do I do this? I can shrink it. So we can always have it for reference. Right here, is that the best way to do this? Okay, so sum of squares. It's also what he used right here, by the way, right? So he gives us two numbers, the sum of x, which is what you would need right here, sum of x, right? Sum of all the x values, all of these, which is 43,757. And he gave us the sum of each x squared. So all the x's were squared and then added together. And that sum was 21,447,047 right here. Right. So this entire thing is this thing. This entire thing within the brackets, of course, is this thing. And you just got to square it and divide it by n. So we're going to do that right now. We're going to take this. Oh my God. Can I highlight it? So lame. Type all that out. Okay, whatever. Forget it. So let's do it here. Equals 2, 1, first 2, 1, 4, 4, 7, 0, 4, 7. Right. Oh, they don't like commas in Excel. Minus parentheses 4, 3, 7, 5, 7. We're going to square that and then divide that by n, which is 90. There's 90 of them, 90 data points. I can read that, right? Yeah, I can read that. Okay. So this is how you get some squares. Get some space. So that's how you would get the sum of squares. This is sum of squares. Is that right? Yes, that is right. Right there. Right. If you want more decimal places, you can do that. Right. More decimal places. You want less decimal places, it'll round up. Right. So at one point, it just round up like that. So he, I guess, rounded up to 2 decimal places. Now we want the variance. The equation for variance is this: sum of squares divided by n minus 1. So variance, which is x squared, is just sum of squares divided by n minus 1. Right? So that is our sum of squares right there. Right there. That's our sum of squares. And that is right. And then our standard deviation is just s. So it's the square root of our variance. So the square root of our variance I don't know how to enter that symbol into this. So it's square root of this, right? And it's SQRT. So this is our standard deviation right here. Yes. This is our standard deviation right here, 44.07. So all these scores were about mathematics performance of 90 countries. At this point, they try to, I guess, throw a curveball and say, oh, guess what? There's also reading scores. And an organization did the same thing you just did and found that the standard deviation for those reading scores is 37.57. Okay, so then now it's asking us to compare. So the country scored more variably in the math than in the reading test because the standard deviation is 44. So there's more variability, right? Whereas here, the variability is less because it's less, it's 37.57. So that's why it's more. What is the US standard score Z in the math test? Okay, so this is what we were talking about earlier, right? Where it gives you a a specific value or something, one of these things, I don't know. But point is, it gives you a specific value. What is the oh, sorry. The later one gives you a specific value, somewhere around here, like this. Oh, it doesn't, my bad. Doesn't give you, no, it does. Okay, sorry. Okay, so specific value, 474. And it wants you to find the z-score. Well, the z-score formula right here is just x minus mean divided by standard deviation. So that's what he did. He took 474, which is the x he gave, one of the data points of the 90 countries, one data point happens to be the US. They got 474. That's the data point, 474 minus the mean divided by standard deviation. Just calculate a standard deviation right here. The z-score is negative 0.2766. I don't think I need to type that in, so I'm just going to write down the answer. Negative 276. I want to, I guess, stress that when you see a z-score of negative 0.2766, you should start to intuitively get a feel for what that means in terms of how the data looks like, right? So if you look back onto this chart, negative 0.2766 isn't past -1, so it's here somewhere, right? Well, you know that 50% of the data is over here. So basically, whatever the z-score is, whatever the United States did, however they did, sure, they were below the mean, right? But they were very, very close to the mean, right? If we got a z-score, if their score was transformed into a z-score and we found that it was -2, that means we suck, right? Because here, right here, that means we would be in the bottom 2 point, like, I don't know, 3%, let's just round up 3%, like the bottom 3% basically, right? If our score transformed into a z-score was -2, but it's negative 0.266, so we're close to the mean, right? So if I had to guess, I would say we're maybe 44th percentile, 41st percentile, right? Just based off the fact that I know the z-score and I'm familiar with the standard normal distribution. You know, just seeing this, I can think, okay, not bad, close to the mean. And that's what the goal of transforming things into normal distribution does. Because later on, when you do your statistics, at least for now in undergrad, all the statistics that you do have this assumption of normal distribution. And so that's what this numbers are based on. And so that's why it's so important. All right. What is the US location in terms of IQ scores? Okay. Well, let's go back over here real quick. So, standardizing scores. SATs are standardized scores. GREs, MCATs, standardized scores. There are other standardized scores like the T score, the IQ score. The only problem is that T scores stay the same, IQ score might stay the same or stay the same for a long time. SAT scores are standardized, but they're always based off of last year's numbers, right? So if last year did a lot better, then next year, you know, you might get the same score, but statistically, you might have a lower percentile because they based the numbers off last year, but it's still a standardized score. So the T score, instead of starting at 0, like the Z score, starts at 50, and every standard deviation is 10. I forgot why, but some analyses don't do well with negative numbers. And so they need a standardized score that isn't negative. So this T-score addresses that issue. I remember doing some research with children with autism, and that happened where we needed to get T-scores because we couldn't run certain types of analyses. I was just like an assistant back then, so I didn't know the details. I just remembered that little fact, right? And so yeah, I guess this is the T-score, starts at 50, standard deviation of 10. That's why, I think that's why they did it. That's why they created it. IQ scores is just what the international community decided on. I don't know who decided it, but basically the mean is 100, standard deviation is 16. So this is equivalent to, did I put that anywhere? Oh, here it is. Okay, yeah, so like this is Z right here. Insert, right? This is Z scores. T scores, Q scores. That's just 50. 16, 2, 60, 70, 80, right? All the same. Plus 1 standard deviation, plus 2 standard deviation, right? Boom. I'm not gonna do this part. I'm assuming you guys can. So now that we know that, answering this question should be simple. We just take our Z-score and we multiply that by the standard deviation to get the standard deviation of the IQ score. The beautiful thing about this set of numbers is that it's basically proportional. So like from 0 to -1, for example, it's a proportion. Like this number, the Z-score, -0.2766, right? It's a Z-score. But at the same time, it just so happens to be proportional. It's not a proportion, just proportional, whereby this could stand as 27.66%, right? Or just positive 0.2766. So if you take this number and you multiply it by anything, you get 27.66% of it. So if I don't know, if I had 30 slices of pie and I want to eat 27.66% of the pie, I just take this, multiply it by 30. That's how much pie I should eat, right? 8.298 slices. And so the beauty of this set of scores is that you can just multiply it, the Z-score, by the standard deviation, which is what he did here. So Z-score times 16. There you go. Which is negative point, did I do it right? Yeah, negative 4.446. And we add that to 100. So 100 and negative, okay, add is just add negative, subtract, so 4.42. This is just in case I lose anyone. It's not really that important, I guess. I do not want equal. Just do that. I don't know what is going on with my mouse right now. There. Oh my freaking God. Okay, whatever. You get the point. I'm not gonna do what I did here. Just know that it's negative negative 0.2766 times 16, right? And so if that US I don't know, percentile location, right, was translated like to IQ scores, this is how much the score would be. Did I make that confusing? Let me see. Oh, okay. Here, this will make it less confusing right here. This question. So suppose the math scores follow a normal distribution, use your z-score to find the percentile rank. Okay, so we're going to enter that in, and that will actually makes it a little clearer. So we took our number 474, the US's actual score. This is made up though. We found the z-score. Well, what does this mean? What does the z-score mean? Well, with this little function, we can know the percentile, and so we can know what it means. Z is negative 0.2766, comma, true, enter, 39.104, right? So that means we scored, I was wrong. I estimated 41 or 44, it's 39. So that means we scored better than 39.10% of the population. Or not the population, the countries, the 90 countries, I guess, of the data under normal standard distribution. We didn't actually do with the data though, remember that. So yeah, 39.1% according to normal standard distribution. And if we want to know our 39.10% in terms of IQ scores, like if we were also, just like we were in math, at the 39th percentile, and we wanted to know, oh, if we're also the 39th percentile in IQ, what would that IQ score be? Well, the IQ score would be right here, 95. Ugh. Ugh, what the? There you go. Right. So that's that. And so yeah, I just did this. That's how you do it. Know this function. Feel free to write it down in your notes. Top 10% of the countries, for the US to be in the top 10% of the countries in math scores, what z-score does the US needs to get? The top 10% or bottom 90%. Okay. So yeah, that's what we kind of did earlier, right? We did that with, I think, top 20, except this time we do with, top 90. So that's the z-score for the top 90. So now transform the z-score into a US score. So this is this problem right here, where before you needed to find the z-score, like in this problem right here, gave you the x, but didn't give you the z-score. So you gotta find the z-score. This one gives you the z-score, but not the x, right? So z-score, but not the x. You have to find the x. So you just plug it in to this equation, right? Do algebra, which is what I did here. Use this equation, and you would get this number. So we would have to score 542.668 in order to be in the top 10%. Okay. And so, yeah, we went over that problem. That problem, if you understand this problem, I really think it will cover a lot of the things on the exam and the Excel part of the exam. But that doesn't mean you shouldn't also know all of these. So yeah, so just know everything here. I don't know if that's everything, but I do know that, I don't know, I'm pretty sure all this would be in the exam. There might be more though, but this will be in the exam. So good luck studying. I will send you all these files and I will send you the links to these 2 videos. So good luck. Email me if you have any questions, and good luck on the exam.